Hello, welcome to Project Lead the Way. Today we're going to be talking about work. Work is a force applied to an object for some distance. We've talked about that in class a little bit. Work is force times distance. So if you apply a force for some distance, then you're doing work. Work equals force times distance, as we've said here. Work is measured in joules. Force is measured in newtons, distance is measured in meters, so a newton meter, or newtons times meters, is a joule. Something I want you to understand, energy is measured in joules. Joules is what we use to measure work. Energy is work. They're the same thing. Two different words that are used for the same thing. It takes energy to do work. If you are doing work, then you're using energy. Energy equals work. I want to make sure that I really specify that. One example of energy is kinetic energy. Energy in motion is kinetic energy. When things are moving, they have kinetic energy. Our equation for this is kinetic energy equals 1/2 mv squared. So some simple examples down here. If we wanted to find the kinetic energy, we would take 1/2 times the mass, which is 1,000, times the velocity squared, 4 squared. With this, then we get an answer of 8,000 joules. 8,000 joules. This is the units we use for energy and work. So we've discussed work. What we're finding out here then is that this 8,000 joules of kinetic energy is because of some work. Right? This boulder could be doing work. We have a 500 kilogram go-kart speeding at 22 meters per second. When we do that, we get 1/2 times the mass of 500 times 22, and that'd be 22 squared, gives us 121,000. What I want you to realize here is that the mass here is half as much. 500 is half as much as 1,000. But because of this square, the velocity means so much when it comes to kinetic energy. The velocity means much more than what the mass does. Although the mass is important, but it's because of this 22 being squared that we get such a huge, much more amount of kinetic energy. Potential energy. All right, this is energy that's being stored. Stored energy. There's lots of different types. The ones we're going to specifically talk about is gravitational. So in this example, we've got an equation up here. Let's talk about the equation first. Potential energy equals mass times gravity times height. We've got this 25 kilogram boy. He climbs 3 meters up into a tree. So, potential energy equals mgh. This boy's mass is 25. Gravity we know to be 9.8. And the height to be 3 meters up. So this boy's potential energy then turns out to be 735. And hopefully you're starting to realize it's joules. The next problem here is we've got a 10 kilogram rock. Gravity again is 9.8 and the height is 9 meters. Then what we find out then is the potential energy of this rock is 882 joules. What this means then is that first of all, this boy has 735 joules of stored energy, which means he could do 735 joules worth of work by falling on something, basically. If he were to fall on something, he would be able to apply 735 joules of work to that object. This rock, if it were to fall, it would be able to apply 882 joules of work. All right, work is easily compared to potential energy. Work is force times distance. Potential energy is mass times gravity times height. Well, look at the units for each. First of all, force is in newtons, distance is in meters. All right. So we could say work is newton meters. If we look over here for potential energy, mg is the weight. Why do we measure weight in the metric system? In newtons. Height we measured in meters. So potential energy are newton meters. So whether we look at, well, here we're seeing that the units are the same. Right? If they have the same units, then they have to be the same. Work and energy are the same. Kinetic energy is a little bit harder, but we still would end up with the same comparison. All right, last slide here. We're going to calculate the following energy and identify if they are potential or kinetic energy. I want you to go ahead and work these out. Remember, our kinetic energy equation is 1/2 mv squared. Our potential energy equation, mass times gravity times height. Gravity, remember, is 9.8 meters per second squared. So what you need to ask yourself, if this thing is moving, right, then it is kinetic energy. If this object is just simply being raised up off the ground, then it's going to have potential energy. Here's the key thing. If they're giving you velocity, it's kinetic. If there's no velocity, if they're giving you a height, then it's potential. Hey, I'll see you on the flip side.